talk about is how do we alter the concentrations of our solutions. We're going to use what's called a dilution formula. We have the first molarity times the first volume, and that will be equal to the second molarity times the second volume. This will allow us to create any concentration that we want. A lot of times the chemical suppliers will sell all different kinds of concentrations of their chemical, but when I purchase chemicals for our lab, I always purchase the most concentrated form I can get my hands on because I can dilute it down to whatever concentration I want. If I purchase less concentrated chemicals from the chemical supplier, I'm paying for a lot of extra water that I could add myself for free. So this formula right here is a real money saver. Let's do a practice question. What concentration of sodium hydroxide would be achieved by adding 2 liters of water to 1.5 liters of a 6 molar sodium hydroxide stock solution? Okay, so the first thing we're going to do is write down our dilution formula. Now we need to decide what of these numbers represents which of these variables. Okay, so they said right here achieved. That means that it's going to happen after something else. So they're asking what concentration of sodium hydroxide would be achieved by adding this amount, this volume of water, to this volume and molarity right here. So this must be the original molarity, and this must be the original volume, and this must be the second volume, and so I'm trying to figure out what the second concentration or the second molarity is going to be. So I'm trying to find out what M2 is. So let's resolve this equation here for the second molarity. Alright, and now all we have to do is plug in our given information. And we come up with a 4.5 molar solution of sodium hydroxide. So we have diluted it from 6 molar to 4.5 molar. Okay, let's do another question. A chemistry teacher is preparing for a lab for his chemistry students and has calculated that he needs 55 milliliters of a 6 molar stock solution of hydrochloric acid. He has a 12 molar solution of HCl in the chemical supply room. What volume in milliliters of the stock solution should he use to create the desired HCl solution? And what volume of distilled water would have to be used to dilute the 12 molar HCl solution to the correct molarity? Alright, let's answer question A first. We're going to need to write down our dilution formula. Now we need to decide what we are being asked to solve for. It says what volume in milliliters of the stock solution. Stock solution means that that's what we already have on hand. It's the thing that we're starting with. Since we're starting with it, it must be on this side. So they are asking for V1, the original volume. So we need to resolve this equation for V1. Now all we need to do is plug in our given information. Okay, so when we do that, we come up with 27.5 milliliters of HCl, and that is our answer to letter A. Now, of course, we need to adjust for significant digits. It looks like 2 is the fewest number of sig figs, so we need to bump that up to 28 milliliters. Alright, now for part B. What volume of distilled water would have to be used to dilute the 12 molar HCl solution to the correct molarity? Okay, so right here we found out what volume of HCl, the actual acid, is that we need to use, but we don't know how much water to add to this much hydrochloric acid. Here's how you do it. This 55 milliliters here is the entire amount of solution that you're going to end up with at the end. That's what this chemistry teacher is going to use for his lab. Now, inside of that 55 milliliters is going to be acid and water. We just calculated how much acid is going to be in there. We don't know how much water is going to be in there, but we know that both of them are going to have to add up to be 55 milliliters. So we're going to do 55 minus the 27.5, and that'll tell us how much water we have to add. So we have 55 milliliters of the solution minus 27.5 milliliters of the concentrated 12 molar hydrochloric acid, and that's going to give us 27.5 milliliters of our distilled water. Notice how we got the 27.5 here and the 27.5 up here. The reason is because we are exactly halving the concentration of our stock solution. We went from 12 to 6, so we went down by 1/2. That means that half is going to be acid and half of it's going to be water. If I had chosen a different concentration for our lab, or if the stock solution had a different concentration that wasn't exactly half, then that means these numbers would be different. But I chose this so that it was easy for us to see the problem here. So you're going to have 28 milliliters of the acid, and you're going to have 27.5 milliliters of the water. Remember, our significant digit rules are different when we do addition subtraction. In that case, we answer with the fewest number of decimal places. This one goes out to the tenths place, this one goes out to the hundredths. That means our answer needs to go out to the tenths place. So this actually is the final answer for part B, and this one's the final answer for part A. Now, in an actual lab situation, if you were really doing this, you would want to do the 27.5 for both of them.